Okay, this is the second video of the current balance lab. So in this video I will explain how this current balance works and the basic idea of the lab. Okay, so current balance has two parts. So this is the base of the current balance. We have one wire, very good conducting wire, and these are good conductors. They are connected, so this is like a one piece of conductor, and here you have two conductors, but this is an insulator, so they are not connected. So they are two separate conductors, they are not connected, and we're going to support, or we're going to balance the this part of the current balance on these two supports. Now this is the upper section of the current balance, which has this conducting wire. It has three sections: this section, this section, this section. They are all connected, and this wire is connected to this piece of conductor, and which is a knife edge here. So you can see the knife edge, and the other side, which is very similar, you have another knife edge. So we're going to balance this, or we're going to support this upper section of the current balance using these knife edges. And there's a mirror connected to this current balance apparatus, or the upper section of the current balance apparatus. And so I'm going to keep this, I'm going to put this on the base. Now you can see when this upper section is moving, the mirror attached that is moving with that. You can see that. So we use that to get the position of the upper section. So later you will understand what I mean by the position. Okay. And I can use these counterweights to balance the upper section of the current balance on the these knife edges, and it can freely move up and down like this. Okay, now I'm going to mark the starting position of the upper part of the current balance. Now you can see here I put the spacer in between these two wires, this wire and this wire, and they are separated, and I want to mark that position. To mark that position, I'm going to use this laser beam. Now the laser beam is focused on the mirror, and you can see it here. This is the laser light, and this is reflected back by the mirror, and now you can see the reflected light on the tube. So I'm going to just a little bit so that I can get that into the middle. Now I want to mark that position. To do that, so I'm going to put this paper so that this line is exactly, or the laser dot is exactly on top of that line, on the middle of that line, position of the upper part of the current balance. So if I remove this one now, if I remove it this way, you can see now that is moving. So I want to use this counterweights to get that laser beam to the original or the initial position. So it's like little above the marked position, so I have to bring this down. Now I use these counterweights to bring this current balance or the upper part of the current balance to the same position. Now you can see that laser dot, which is came back to the same position. Now I know the space between these two wires, which are in the same value as before. Alright, so this is the next part we need to understand. So you know, when we send a current through any conductor, it creates a magnetic field. So we're going to send a current through these wires in opposite direction, and when you send current in opposite direction, there's a magnetic forces acting on them, and they will repel each other. So when you send a current, these wires will repel and this will go up. Only this can move because this is fixed, it cannot move. So this will move upward if you send two currents in opposite directions. So in order to bring that back to the same position, we can put some weight, or in vice versa, we can put some weight on this upper wire, and now they are close, and you can see the laser point, which is not in the original position. In order to bring that into the original position, we can send a current through these wires, and when you send that current, they will repel, and if you send the right amount of current, you can bring that back to this original position. Now we're going to connect the circuit to send a current in this current balance wires. Okay, first turn off the power supply, and you can see this is the positive terminal of the power supply. So I'm going to get a current from there to the resistance box, and from there I'm going to get a current to this point. Now this current, it cannot go in this direction because these 2 points, they are not connected. So this current going to go in this direction and go with this direction and come to this point. Now the current cannot go in this direction because these 2 points are not connected, so this will go to this conductor, and we know this conductor is isolated. Now I want to send the current in the lower wire, in this wire, in the opposite direction. So current is coming in this direction in the upper wire and coming in this direction, and I'm going to connect wire here, and in the other end of the wire I'm going to connect it here. Now the current is going back in the opposite direction in the lower wire. Now I have the same current going in these two wires, but they are going in the opposite direction. Now current comes to this point, go back to the go to the ammeter or the multimeter, then from the multimeter it go back to the negative terminal of the power supply. So I have the complete circuit. Now we can send some current and see what will happen. Okay, so I'm going to turn on the meter. So I turn on the meter and there's no current in the circuit. Now I'm going to turn on the power supply. And I'm going to use very low resistance, about 2 ohms. Let me show you the laser point, and you can see it is in the original position. So we know the space between these two wires are equal to the diameter of this spacer. Now let's send some current and see what will happen. Now you can see there's a current in the circuit. So I'm going to increase the current. So now it is almost 2 amps. now it is 4 amps, and you can see that laser beam is moving upward because these two wires, they repel each other. Okay, now there's no current in the circuit, and these are the two wires, and the separation between these two wires equals to the diameter of our spacer. Now I'm going to increase the current. Okay, so this is the current. I'm going to increase the current in this circuit and see what will happen with these two wires. Okay, now I'm going to increase the current in this circuit gradually. You can see this is the current in this circuit. Here, this is my meter, and you can see there's no current now actually, so you can see the current. So current is increasing, and now you can see the upper wire is slowly moving. It's moving now. Okay, so now current is 6.38 amperes. So I'm going to increase that gradually, and you can see the separation between the wires increasing. Okay, see that? Alright, so I'm going to decrease the current again from 9 amperes to low value, and now you can see the separation between the wires gradually decreasing. Why? Because low current produces low magnetic field. If the magnetic field is low, the the force, which is BIL, decreasing. No current in the circuit now.